Hello everyone and welcome to day 3, exact values. Today we're going to be using the information we already have learned about trigonometry to find exact values of certain trigonometric functions. So the first thing we're going to look at is a thing called the unit circle. The thing that we know about the unit circle is that it's centered at the origin. Apologize for my circle that I drew. And it has a radius of 1. So we know that that point is 1, 0. This point is 0, 1, negative 1, 0, and 0, negative 1. Because it has a radius of 1, that's why those points all exist. From our work before, what would the equation be? Well, we have a center of 0, 0 with a radius of 1, so it would be x plus 0 squared plus y plus 0 squared equals 1 squared. Well, clearly it must be number 3 then. The center is 0, 0, square root of 1 is 1. So now what we're going to look at is how to find exact trig functions for specific kind of triangles. Now, the first triangle that we're going to look at is a 45, 45, 90 triangle. And with this, we know that it's an isosceles triangle because from geometry we have two angles that are the same. And so therefore, we know that this triangle came from the unit circle. If you want to go back up here and look at this, the unit circle, if we're going to do a 45, 45 triangle, it's going to look something, if my circle had been perfect, where that's 45 degrees, that's 45 degrees, and that's 90 degrees. And so why is the radius, why is the hypotenuse in this case 1? Is because that's the radius. The radius is 1 here. It's the hypotenuse. It's the center from the origin out to the circle. And so that's where we get this idea that the hypotenuse is 1. And so what are we looking for? We're looking for x. Well, we know that since it's a right triangle, x squared plus x squared equals 1 squared. And x squared plus x squared, an apple plus an apple, we get 2 apples. It's not x to the 4th equals 1. We'll divide by 2. And we're going to get x squared to equal 1/2. Now, to get rid of the squared, we'll square root, so x equals plus or minus the square root of 1 over 2. Why don't we need the negative? The negative is only if it had negative distance. We know that negative distance doesn't exist, and so what we're looking at is that x equals the square root of 1 divided by 2. Just so you guys know what else it could look like, we can split up the square root into two separate square roots, which is square root of 1 over square root of 2. And the square root of 1 is just 1, so we could also write it as 1 over square root of 2. So either answer works, just so you guys know that. The next triangle that we're going to look at is called a 30, 60, 90 triangle, where the hypotenuse is again equal to 1, it's the radius of the unit circle. Clearly this is a half of an equilateral triangle. It may not be clear, so let's look at it. If I have a 30, 60, 90 triangle right here, if I extend it, if I duplicate it, so this triangle is now reflected over the vertical line, this is also going to be 30 degrees, this is going to be 60 degrees, and therefore this entire angle right here is 60 degrees. And now we have an equilateral triangle, meaning that this portion right here, just this portion of a 30, 60, 90 triangle is half of that portion. And so if we have 1 here, if we have this being 1, then we know that this is 1/2, because all of that would be 1. It's an equilateral triangle. So the only thing we don't know is the altitude, which is x. What I'd like you guys to do right now is pause it, use the Pythagorean theorem using 1, x, and 1/2, and try to solve for x. Unpause it, and I'll have the answer for you. So using the Pythagorean theorem, find the length of the shortest side. We set it up. How did I get 3/4 right there? We took the 1/4 and subtracted from 1, which will give you 3/4. Square root it. You reject the negative. I didn't even bother putting it in there, but you would have plus or minus, reject the negative. Square root of 4 is 2. You're left with square root of 3 over 2. And so now you know all 3 sides to a 30, 60, 90 triangle or 45, 45, 90 triangle. Why don't you pause it and we'll just draw those triangles right here just as a reference. And so what we have here is a 45, 45, 90, square root of 2 over 2, square root of 2 over 2 and 1, and a 30, 60, 90, square root of 3 over 2 and 1/2. Remember that the largest angle represents the longest side, and therefore that's why 60 is the middle angle, it's square root of 3 over 2. 30 is the shortest one, it's 1/2. So when we have this unit circle here, we're looking at this 30, 45, 60 triangle. Remember that that point we talked about before is the point 1, 0. Now this angle right here is 30 degrees. That's what this point, that's what that angle degree is telling us. Well, if we have a 30, then this angle must be 60, and that's 90. So we have our 30, 60, 90 triangle right here. But we just talked about 30 degrees is small, so that must be 1/2. That means that our y value is 1/2. That's how much we went up. And then therefore, this side is square root of 3 over 2. And so therefore, that point at 30 degrees, when you rotate 30 degrees on the unit circle, that point is the point square root of 3 over 2, 1/2. It's based on the 30, 60, 90 triangle, where the shortest side is 1/2, that represents the y value, and the longer side, the middle side, because we know that the radius is 1 here, is square root of 3 over 2, and that's the x value. We'll go use a different color here. This triangle right here is a 45, 45, 90. If we look here, that's 45 degrees. This is then 45 degrees because we know this has to be 90, and it's now an isosceles triangle. We know that each of the isosceles triangles, when you look over here, square root of 2 over 2 and square root of 2 over 2, which then means at that point, square root of 2 over 2, square root of 2 over 2, or 1 over square root of 2. Just remember that. Side note, you may be wondering where I got square root of 2 over 2 when we talked about on the previous page 1 over square root of 2. It's a good thought. I hope you guys are thinking this. When we get 1 over square root of 2, we used to use something called rationalizing the denominator, which was multiplying by square root of 2 over 2, or square root of 2 to both the top and bottom. That's only multiplying by 1. When you do that, you're going to get square root of 2 over square root of 4. Square root of 4 is just 2. This was old school thinking. So we usually do, and I'm sorry for reverting back to that, we can revert what we have learned as 1 over square root of 2. So know that that is also 1 over square root of 2. I just wanted to show you where I got square root of 2 over 2 from. So hopefully you were thinking that, and yes, if you had put 1 over square root of 2, that is correct. Moving on, we now have the 60 degree angle. We can look at, this is now a 60, 30, 90 triangle. And know that this is the shorter side. 1/2 here, square root of 3 over 2, is the longer side, and therefore our point now is 1/2 square root of 3 over 2. And notice that these 2 points, the blue and the green, are just switched. That's all it is. They're just switched because the triangle has just been rotated. So please note that the 30 and the 60 degree triangles are just rotated in different positions, and the x and y values have just switched. What I'd like you guys to do is pause it and fill in the rest of these coordinate pairs, knowing that in like quadrant 2, what we already talked about is that the x value is negative, the y value is still positive. So please take a minute right now and fill in the rest of the unit circle for each of the angles given for a coordinate pair. And so hopefully you get this unit circle. You will notice one of the key things here is that all the x values are negative here. All the x and y values are negative there. Don't know why I just did that. And all the y values are negative in quadrant 4. Again, that's going to come into play when we look at the sine and cosine functions, which we already have in day 1. But there's your unit circle. Very important to know these. Know the 30, 60, 90 triangles, and then you can do any of these points. One other thing that you can look at is just notice here 60 and 120 also have the same reference angle, which we'll talk about. But notice the same reference angle, 60 degrees from the x-axis, 60 degrees from the x-axis here. Same points, just one being negative. Same as 150, 30 degrees from the x-axis, 30 degrees from the x-axis. Same points, just one being negative. So let's look at exercise 5. So it says find the coordinate pair. 60 degrees should be straightforward. You look at the unit circle, you're going to get 1/2 square root of 3 over 2. Negative 120 is not as obvious. Negative 120, you're going to have to add 360 degrees, or just look at the unit circle and go backwards 120 degrees. You're going to be at 240, which must mean negative 1/2 comma negative square root of 3 over 2. Or 495 degrees is all the way around a circle, and then another 135 degrees again, 135, negative 1 over square root of 2 comma 1 over square root of 2. So those are how you're finding the coordinate pairs. I'm going to have you pause and do exercise number 6. Remember that sine is the y value, cosine is the x value of the coordinate. So pause and do that. I'll give you the answers and we'll move back on. Pause it, check to see if you got the right answers. Notice that this is negative. We're in the third quadrant, therefore it's negative. All the rest are positive due to the quadrants they're in. Please read the following parts, so pause it and read the following parts, and then we'll look at reference angles. And so I had started to talk about reference angles before. Reference angle is the distance from the x-axis, and therefore, reference angle, if we look at it, it is the distance away from the x-axis no matter what direction we're going in. So just make sure you understand that, reference angles. Exercise number 1, I'll do the first one. You can pause it. You guys do the second ones and check your answers. 145 degrees is more than 90 but less than 180, so we go more than 90, and it falls right a little over half of in the second quadrant. And there's your theta of 145. What I'd like you guys to do is try the next 7 of them, doing the same idea. That means pause it and actually try it, not just copy. So pause it, take a minute, make sure you got the answers correct, and I'll see you on the next page. So in which quadrant would the terminal angle of the standard position fall off the measure was 860 degrees? So we can think of it a couple ways. Minus 360, that's all the way around once, gives you 500. So minus another 360 can give us 140 degrees. So we went all the way around again. Another 140 degrees is beyond the 90 degree mark, but not close to the 180 mark, so we're in quadrant 2. Looking at exercise number 3, a negative angle. To get a negative angle, you're going to subtract 360. So why don't you guys subtract 360, see what negative angles, and then see if you got it right. And there are the 4 answers. So pause it if you need to. A great question here. Coterminal angles drawn in standard position will always have measures that differ by a multiple. Again, coterminal, always going to be around and end at the same spot, and so therefore 360 degrees. This is for each of the following. For number 5, draw a rotation diagram and then state the reference angle. So this is the important part, and I was talking about this before. The reference angle, so 160 degrees is right there. What is this distance? What is this distance right there? And that answer, to get to 180 degrees, would be 20 degrees. And so the reference angle, beta r, equals 20 degrees. For 300, 300 is in the third quadrant, right here. How much to get to there? Well, you would go all the way around, it would be 60 degrees. So your beta, your reference angle, is 60 degrees. Let's think about 210. 210 is beyond the 180 mark, but by how much? Because the distance again to the x-axis is that part, not to the y-axis, to the x-axis. That portion right there is 30 degrees. So the reference angle is 30 degrees. Trick question here, the reference angle at 78, notice it's in the first quadrant, it's just that distance. 78 degrees is your reference angle. It's again the distance to the x-axis. I should state again, it's not the distance, it's the angle measure to get back to the x-axis. Should not be using the word distance. But here we go. Let's look at E, and then we'll have to switch videos. Negative 110, this far, right there. That's negative 110 degrees. What is this angle measure? Well, negative 110 degrees, this angle is 20, so then this angle must be 70. So therefore the reference angle is 70 degrees. Pause this or stop this video, and then we'll go to the second video.